You don't feel it bite. You feel the itch 4 days later, when it's already too late to matter, when the thing that bit you has already fed, already defecated into your skin, already handed off its cargo. And somewhere in a body louse smaller than a grain of rice, a bacterium has just won the easiest war of the entire war. Nobody in 1914 packed for this. They packed for shrapnel, for gas, for machine guns that could end a life in the time it takes to say the word advance. Nobody packed for lice. And yet, by the time the war ended, this insect, this genuinely unimpressive, wingless, six-legged nuisance, had passed through more than 1 million soldiers. Not killed, passed through, which, as you're about to learn, is so much stranger than killing them. Here's the thing about trench warfare that nobody tells you in history class. It wasn't just a battlefield, it was a habitat, and habitats have residents. Soldiers lived in the same uniform for weeks, sometimes months. No laundry, no regular bathing. Bodies packed into narrow mud corridors, sleeping shoulder to shoulder for warmth, sharing blankets because the alternative was hypothermia. From an epidemiologist's perspective, and yes, I think about this the way other people think about traffic patterns, that's not a war zone. That's a 5-star resort for body louse. Pediculus humanus corporis, the human body louse. It doesn't live on your skin, it lives in your clothing, in the seams, and only visits your skin to feed, which means every uniform on the Western Front was, functionally, a second organism, a wearable ecosystem, quietly humming with a population that outnumbered the men wearing it. I want you to sit with that for a second, because I think it's the funniest and most horrifying fact in this whole story. The average soldier wasn't infested with lice. The average soldier's clothing was infested, and the soldier was just the delivery mechanism the lice used to get fed. Evolution didn't design the louse to hurt you. Evolution barely designs anything on purpose. It's less an engineer, more a contractor whose warranty expired 3 million years ago and who's just improvising with whatever's lying around. The louse needs blood. You have blood. That's the whole plan. The disease part is an accident, a magnificent, world-altering accident. Let's slow down and actually watch this happen, because the mechanism is genuinely beautiful, and I will die on this hill. The louse lands. It doesn't inject anything through its bite the way a mosquito does. That's the part that throws people. This isn't a hypodermic needle situation. The louse feeds, and while it feeds, it also defecates. Right there, right next to the bite. Inside that feces, Bartonella quintana, a slow, stubborn, gram-negative bacterium that has been quietly living in the louse's gut. The bacterium doesn't need to be injected, it just needs an opening, and you're going to give it one, because the bite itches and you are a human being with fingernails and you are going to scratch. Congratulations, you've just done the pathogen's job for it. You've rubbed infected louse feces into broken skin. Sometimes it doesn't even need broken skin. It can slip through the soft mucous membrane of the eye if you rub with dirty hands. This is one of my favorite things about Bartonella quintana. It doesn't have a delivery system. It has a marketing strategy. It makes you itch and it waits for you to do the rest. Known, the bacterium is transmitted through louse feces entering broken skin or mucous membranes, not through the bite itself. Hypothesis territory, exactly how long the organism survives outside the louse in dried feces on clothing, is still debated, which mattered enormously in the trenches because it meant the uniform itself could stay dangerous long after the louse that made the mess was gone. Here's where it gets unsettling in a very specific, very medical way. Nothing happens. Trench fever has an incubation period of 2 to 4 weeks. For 2 to 4 weeks, the bacterium is inside you, and you feel completely, boringly normal. You're on watch, you're writing letters home, you're complaining about the food. Meanwhile, Bartonella quintana has found its favorite piece of real estate in the entire human body, the red blood cell. Most bacteria that manage to get inside a red blood cell get destroyed for their trouble. Red blood cells aren't exactly hospitable, they're basically oxygen delivery trucks with no immune machinery of their own. But Bartonella has a party trick. It attaches to the outer membrane, and instead of forcing its way in like a burglar, it essentially convinces the cell to fold around it, inviting itself in through a process that looks less like invasion and more like being handed a key. Once inside, it's shielded from a huge portion of your immune system, which is very good at finding things in your blood plasma and comically bad at finding things hiding inside the very cells meant to carry oxygen. It replicates there, slowly, patiently, building up numbers while you have absolutely no idea any of this is happening. I love this bacterium the way you'd love a chess player who's already won the game 3 moves before you notice they're playing. You wake up and your head is pounding in a way that doesn't feel like a normal headache. It's sitting right behind your eyes, like someone's pressing a thumb into both sockets from the inside. Your shins ache, not your knees, not your thighs, specifically your shins, a deep, gnawing bone pain that makes no sense to you because you haven't hit them on anything.
Fever comes on fast, 90 minutes, maybe 2 hours, and you go from fine to shaking, 103, 104. You assume it's the flu or exhaustion or the cold mud finally catching up with you. Then, and this is the part that made army doctors lose their minds for 3 straight years, it goes away, completely. You feel almost normal for 4 or 5 days. You go back to your post. You start to think you imagined how bad it was. And then it comes back. Same fever, same shin pain, same crushing headache behind the eyes. Some men had 1 relapse, some had 5, some had it come back over and over for months, this strange biological tide rolling in and out on an almost perfect 5-day rhythm, which is exactly where the bacterium eventually got its species name, quintana, from the Latin for 5th, because physicians noticed the fevers kept returning roughly every 5th day. Your immune system, God bless it, is trying its best. It means well. Results vary. It detects the bacteria circulating in your plasma between hiding sessions and mounts a real aggressive response. That's actually what the fever is. Fever isn't the disease attacking you. It's your own body raising the thermostat on purpose, trying to make conditions worse for the invader than for you. It's a deliberate, coordinated act of self-inflicted discomfort in service of a longer-term goal, which is either the most heroic thing your body does or the most passive-aggressive, depending on how the week is going. The problem is that Bartonella quintana has a hideout your antibodies can't fully reach, inside those red blood cells, so every time your immune system thinks it's cleared the infection, a fresh wave emerges from hiding and the whole cycle restarts. It's less a war and more a stalemate with a 5-day intermission. And here's the detail that genuinely surprised the doctors studying this in real time, working the wards behind the front lines. Trench fever almost never killed anyone. Debilitating, yes, brutally so, but mortality was rare. What it did instead was something arguably more dangerous to an army. It took a soldier who was completely fine 1 week and made him unfit for duty for 2 months. Not dead, not obviously wounded, just gone from the line for 2 months, over and over, in the hundreds of thousands. More than 1 million soldiers were infected with trench fever during the First World War. Every single one of those soldiers was unfit for combat duty over 60 days on average. Sit with that math for a second, because it's not really a medical statistic, it's a logistics catastrophe. A bullet removes 1 man, sometimes permanently, sometimes for weeks. A louse, working on a 5-day cycle, removed men from the line for 2 months at a time, in numbers that dwarfed almost anything artillery managed to achieve directly. Some historians studying the medical side of the war have gone as far as suggesting that this bacterium had the lethality of its far more dangerous cousin, the one responsible for epidemic typhus. The entire trajectory of the war might have looked different. It's an uncomfortable thing to say out loud, but it's true. An organism you needed a microscope to see was doing more strategic damage to troop readiness week over week than most single battles on the Western Front, and for 3 straight years nobody could prove why. True or false? Doctors in World War I knew immediately that lice were causing trench fever. Verdict: false, spectacularly false. Reality: the first case was documented in June 1915 by a British military doctor examining a soldier with a recurring fever, crushing headache, and severe shin and lower back pain. Body lice were suggested early on as a possible vector. Soldiers were obviously infested and the correlation was hard to ignore. But suggesting a link and proving one are very different things in medicine. For roughly 3 years, transmission and cause were fiercely debated among military physicians. Some suspected respiratory transmission, some suspected contaminated food or water, some thought it might be an entirely new pathogen never before seen in humans. It took until 1918, 3 years into the outbreak, with more than 1 million cases behind them, for 2 separate medical commissions to conclusively demonstrate that lice were the vector, after researchers found the bacterium consistently present in the gut and feces of lice that had fed on infected patients. Even then, they couldn't grow the organism in a lab. The specific bacterium wasn't successfully cultured until the 1960s, nearly half a century after the war that made it famous. For most of its own epidemic, trench fever's cause was, medically speaking, a complete mystery being fought with guesswork, delousing stations, and the desperate hope that clean uniforms might help, which, as it turns out, they absolutely did, even before anyone understood why. Fast fact: the louse can't fly, can't jump. It has to crawl, seam to seam, garment to garment, which means the crowding of trench life, men packed together in shared dugouts, swapping blankets, sleeping in shifts in the same warm spot, was doing more to spread this disease than almost anything the lice themselves were capable of on their own. Delousing became an entire logistical operation. Armies built portable steam and dry heat stations specifically to bake uniforms and kill both the lice and their eggs, because boiling water and heat were reliably lethal to an insect that antibiotics hadn't been invented to treat yet. Trench fever isn't new. It isn't even new to war. Researchers analyzing ancient dental pulp, DNA preserved deep inside teeth, which turns out to be an excellent time capsule for blood-borne bacteria, found traces of this exact organism in skeletons dating back roughly 2,000 years, including soldiers from Napoleon's army in 1812. The bacterium didn't invent itself for World War I. World War I just built it the perfect stadium.
And it never really left. Because Bartonella quintana still needs the same 3 ingredients it needed in 1915: body lice, close crowded living conditions, and infrequent bathing or clothing changes. It still shows up today, quietly in homeless populations, refugee camps, and anywhere those same conditions recur. Same bacterium, same insect, different century, same unglamorous recipe. I want to be honest with you here, because scientific honesty matters more to me than a clean narrative. Trench fever itself was rarely deadly. That part is well established. But Bartonella quintana has a longer, quieter second act that most people never hear about. In a small percentage of cases, somewhere around 5% based on wartime and post-war observation, the infection doesn't fully clear. The bacterium persists in the bloodstream at low levels for years. Sometimes it resurfaces as a relapse over a decade later. And in some of those chronic cases, decades on, it's been linked to a much more serious complication, a slow, smoldering infection of the heart valves called endocarditis, which can be genuinely life-threatening and is notoriously difficult to diagnose because standard blood cultures often come back negative. The organism is famously hard to grow outside the body, the same trait that stumped researchers for 50 years. This is the part of medicine I find almost impossible to explain to people outside it. An infection can look completely resolved, feel completely resolved, and still be sitting quietly in your blood, rewriting its own ending years down the line. The body doesn't always close its books when you think it does. Here's the twist that still makes me laugh, in the specific, slightly unhinged way that medical history sometimes deserves. Delousing worked. Clean uniforms worked. Heat treatment of clothing worked. Armies were already reducing trench fever cases before anyone had proven lice were responsible, simply because hygiene measures happened to also solve the problem nobody had diagnosed yet. Sometimes the cure doesn't wait around for the science to catch up. It just quietly does its job while the doctors are still arguing. The actual antibiotic treatments we use today, doxycycline, sometimes paired with other agents for the more stubborn chronic cases, didn't exist yet. Antibiotics as a medical category were still decades away. So for the entire war, the treatment was essentially environmental. Kill the vector, break the cycle, wash the uniform. It's not glamorous, it's not a miracle drug, it's laundry functioning as frontline medicine. And it's one of the strongest reminders in the history of infectious disease that you don't always need to understand a mechanism perfectly to interrupt it. I think the instinct when you hear 1 million soldiers infected by lice is to file it under horror. Gross bug, gross disease, wartime misery, next video. But that's not actually what fascinates me about it, and I don't think it should be what fascinates you either. What I find remarkable is how much this outbreak reveals about how infectious disease actually spreads. Not through dramatic single-event catastrophe, but through crowding, through fatigue, through the small compromises people make when they're cold and exhausted and haven't changed clothes in 3 weeks. Trench fever wasn't a monster. It was an opportunity that circumstances handed to a bacterium that happened to be very good at waiting. And the debate over its cause, 3 years of confusion, competing theories, contaminated food versus airborne spread versus insect vector, argued by serious, credentialed physicians who simply didn't have the tools yet to see what was actually happening, is a genuinely humbling reminder that medicine is less a fixed body of knowledge and more a live argument that occasionally gets settled by extremely patient people staring at lice under primitive microscopes in field hospitals. Medicine is really just professionally admitting that nature has better lawyers than we do, and every so often we win a case anyway. You're probably not fighting in a World War I trench. I'm aware of that. But the underlying rules haven't gone anywhere, and they're worth carrying with you. If you're ever in a setting with crowding, limited hygiene access, and shared clothing or bedding for extended periods, a shelter, a refugee situation, extended fieldwork, or disaster response, body lice and the organisms that ride along with them are still a real documented risk today, not just a historical curiosity. The fix hasn't changed in over 100 years. Regular clothing changes, heat treatment of fabric when possible, and prompt attention to a recurring, unexplained fever with severe headache and shin pain, especially one that seems to vanish and then return on a suspicious rhythm. And if a doctor ever tells you an infection has resolved, it's worth remembering that resolved and gone aren't always the same word. Some organisms don't leave, they just go quiet. Chronic low-level bacteremia is a real and documented phenomenon, and it's part of why physicians take a strange, persistent fatigue or unexplained recurring symptoms seriously years after an apparent recovery. But mostly, I want you to walk away from this thinking about the sheer scale of what a single, wingless, flightless insect the size of a sesame seed managed to do to the most heavily armed conflict in human history up to that point. Not through venom, not through any weapon at all, just through patience, crowding, and a bacterium that figured out how to hide inside the one cell type your immune system can barely search. That's not horror to me. That's one of the most quietly impressive stories biology has ever written. If you want more videos like this, subscribe.